So in this video, we're actually going to talk about something new to me that I had to actually go and research myself, and that's Quark gluon plasma. Okay, I know it looks like Quark, but it's Quark. That's how we pronounce it, like the cork in a bottle, but with a Q noise. All right, so Quark gluon plasma. And your objective for today's lesson is I want you to be able to explain what the Quark gluon plasma is. There are two terms that you should be able to explain by the end of this lesson, and that is what is a quark and what is a gluon. All right. Fantastic. So let's begin. We've all learned that everything is made of these things, atoms, and this is kind of what they look like. So in the middle, we have the nucleus. We spoke about that last term. And then around it, we have these things spinning. These little things are called electrons. Okay, so plasma is created when an atom receives so much heat and so much energy. These electrons that are spinning around actually stop orbiting. They leave their nucleus entirely, and they're off having the time of their lives, just freedom, bouncing around wherever they want. They're no longer held in an orbit. All right, so that's what plasma is. Just give it enough energy and an atom is going to lose its electrons eventually. All right? Now, a quark gluon plasma is super rare. It's when we take a plasma and we superheat it. I mean, heat it hotter than the heat from the sun. Okay, if we took the energy from the sun, we would struggle to get the amount of energy needed to create a quark gluon plasma. All right, so let me start. We know about the atom. We know about these electrons buzzing around. Heated enough and the electrons leave. That's average almost compared to what we're about to learn about. In the middle, we have these two things, neutrons and protons, okay? And if we heat an atom enough, we can actually make those protons and neutrons spread out, which is impressive. But if we keep heating it and keep energizing it, we can actually break those protons and neutrons into smaller parts. And they're called quarks, which are these things, the U, and the D. Those are called quarks, which are just smaller things inside atoms and neutrons. And then in between, the stuff gluing them together is called a gluon. And if you get enough energy in them, you actually rip those things apart. And when we get that, then that's the new state of matter known as a quark gluon plasma. If we continue to heat the plasma, the nucleus and protons in the nucleus will start to move out of the nucleus. I said that. And then soon the heat will become so hot, the neutrons and protons will start to break apart into the parts that make them up, quarks and gluons. And at this point, we've got a quark gluon plasma, okay? And that's the new state of matter. So before I answer, what is a quark gluon plasma like? Remember I told you that plasmas glow and they're kind of like a gas, but they're superheated. Now the properties of a quark gluon plasma is, I don't know. I really don't, boys. It's what we're talking about here is at the cutting edge of science. So you should have heard about this. This is the Large Hadron Collider, also known as CERN, C-E-R-N. This is the cutting edge. This is the sort of stuff they're studying, because the only place we can make particles hot enough or atoms hot enough is over here. You see these big loops? Those are underground tubes, and they fire atoms as fast as they can, almost a few fractions of the speed of light, until they hit each other. And when they hit each other, then there's enough energy there for them to become quark gluon plasma. But they only exist for a few seconds before they cool down and go back to normal. So there is some idea of what they behave like and what a quark gluon plasma is like, but that's beyond me. Okay, and I can keep reading, and I will keep reading, but yeah, boys, if you're interested in this sort of stuff, if you're interested in what's called particle physics, this is what you'll be studying someday. But yeah, thanks for the question, boys. This is, I enjoyed learning about it. Hope you did too. Have a fantastic day.